What's up guys, Shawnthebro here, and today we're going to be going over tilting and rotating the camera at specified times for the character. So specifically for me on a button press, I want to be able to tilt and actually be able to shoot like farther away. I can tilt both directions. So if I'm around this wall like I am here and I can't hit, say, that guy, I should be able to tilt and then hit him. Just like that. Today's going to just basically be code changes. One simple function that I call tilt right, just like the game does move right and things like that. We're going to be doing a tilt right function that's going to take care of everything we need to perform this tilt. Let's get started. If we go into Edit, Project Settings, and go into Input, then you can see I've added a tilt right axis mapping. As I've said, it's kind of just like move right or move forward. Essentially, one direction is defined in the name, such as right in both of these cases, and then the button that would move you or make you turn or tilt in that direction is the positive value, and the one that would go away from that is the negative value. Now on a joystick or some sort of thumbstick, the left is one value, right is another. But when you're using just keys, you just use two different keys. So for tilt right, I'm using num1 and num3. So num1 on the numpad and 3 on the numpad. 1 is left, 3 is right. All that matters is that you have one button that's -1 and another button that's 1. Then, once you've done that, we can go into the code and set this up. Make sure you go into your tutorial character header file. Now, if you haven't been following this series, we are going to be using some stuff that we've used in the past. You can follow this without watching any other part of the series. But if you do want to catch up and kind of figure out what's going on, then feel free to click on this iCard right now to go to the very first episode of the first-person shooter tutorial. We're only a few episodes in. I think we're on episode 12 or so. Just scroll down to where I did it, where I have my move right, move forward functions. But these come with the template anyway, if you're using the first-person template. I went right below that and just made a void tilt right. So once you've made this function, and the comment explains it, it handles tilting movement left and right. It's pretty simple. That's all it really does. We only have to do one more thing before we can actually get into our function and set it up. We need to go down to our setup player input component. Again, this will be in your character already if you're using a first-person template or if you've bound other actions manually. You can go ahead and just add this line right here. You have to bind the axis to the function you want to call. The tilt right binding is going to call the tilt right function. Make sure the name in quotes here matches exactly with the input you added. So mine's tilt right. Again, if you take a quick look at this, you can see that it is tilt right, just like that. Okay, so when any button is pressed, or essentially all the time, since input axes also work with a 0 value, this tilt right function is going to get called and determine if we should tilt or not. So here's the function, and here's the logic. I've commented some of the lines, and some of the values here we should put into variables so we don't have to hard code these and make a change on all these locations every time we want to change them. I'm intentionally leaving them not as variables right now so that I can kind of explain what these values are doing instead of just seeing the name. And then we can go ahead and change them to values afterward. But I actually thought it was easier to explain this in essentially degrees. Alright, so I'm going ahead and calling a function called getControlRotation, which essentially gets the rotation of the pawn, but not necessarily the rotation of the character, specifically of the controller in this case. And what we want to do with that is grab the roll value. The roll is the rotation around the x-axis, and so the x-axis in this case is the one you can see that it says here, tilting your head is in the comment for roll, so that's good. 0 equals straight, positive is clockwise, and negative is counterclockwise rotation. But I'm going ahead and storing this value because we're going to be using this current tilt value a lot here. You can see I use it 4 times in this and about 5 times in this. Actually a little bit more, like 7 times in there. So I figured go ahead and add this to a variable. I just called it current tilt. Then we have 2 cases here. We either have the character, if the character is applying any tilt. If the player is pressing any button, that applies tilt. If the value is not equal to 0, then this value comes from the values we set up in the project settings. Remember, 1 was -1 and 3 was +1, left and right. Well, if the value is 0, neither num1 or num3 are being pressed, so the character is not applying any tilt. So it would go to this else statement. But if this is not 0, then the player is pressing 1 or 3, which means they are applying tilt. So we want to go into this logic. Let's cover this logic first. This is the actual tilting logic. We do have to get the character returned to normal once the player releases the button to tilt, which is why this logic exists. But of course, let's focus on the tilting logic before we do that. Just makes sense. So essentially what I'm doing here is I'm putting in boundaries that I don't want to pass when trying to tilt. You do have to be careful because in this case, the tilt is going off of degrees. So 30 degrees and 330 degrees are exact opposites on a circle. A circle is 360 degrees. So if you start at 0, that's also 360 because those points connect. The 0 degree and the 360 degree connect. That's one full circle. So if you go 30 degrees one way, you end up with 30 degrees. If you go 30 degrees the other way, you end up with 330. So what we need to do is take our current tilt that we're at, add the value that we're going to be adding to it, and make sure it is less than or equal to the bounds that we want to be able to go to. Same with the other direction. Take the current tilt, add the value to it, and then make sure that it is greater than or equal to 330. So remember, our value is going to be negative if we're going counterclockwise, if we're going left. That's why when we add the value, so say we're at 345 and we add a value of -1 here. Well, this is going to be 345 minus 1. So we still want to make sure that's greater than 330. Otherwise, we'll be able to rotate farther counterclockwise than we can clockwise, and that just won't look good. If either of these values becomes true, only one of them will be able to come true at a time. Then, if either of these becomes true, we can go ahead and tilt the character clockwise or right. I went ahead and added a log so that you can see it in the output log when we're playing the game, but it's not required. And what we want to do to actually tilt the character is add controller role input. It's an Unreal function. We don't have to write this. Essentially, it just adds to the controlled pawn a certain rotation, and we're applying it on the roll value, which remember, the roll is the one we want. It's the one we retrieved up here. We don't care about the other rotations in this case. I've also gone ahead and done something a little bit weird that ends up working excellently. So I like doing this function called add actor local offset when you want to just kind of poke the player out from where they're at. When you do this, this actually makes it to where your player will essentially leave the cover so you can see. The thing is, if you just rotate your pawn, you don't actually get anywhere. Think about it. You know when the whole point of a tilt is so you can see around a corner or something, right? What are you doing if you were to do that? You would essentially move your body to the left or to the right to get more of an advantage, more vision on whatever you're trying to look at. Well, if you don't move at all, and you just literally were to rotate your head, then you don't get any advantage. The reason your head rotates is just simply because of the way your body is tilting to see more of it. So, we do need to move the actor if we want to get any effect with that. I went ahead and did it this way because local offset isn't nearly as bad as world offset. Local offset just means it'll move you from, the base of that pawn. So if it's the capsule collider or whatever. And then I'm just doing it by 2. This will happen every time that we roll, which means as the rotation gets farther, we will start moving a little bit more. It's not a huge movement. Like, you can barely tell if you use it somewhere not around a wall. You can tell. But if we go to, like, this wall or something, you can see it's pretty significant. Now, the bullets on this gun are huge, so you can't even see it when I'm shooting it here because it's just bouncing off right away. But now you can see I'm able to shoot around the corner, and that's what we want. Now, the good thing is, when we do the return from tilt, we're going to do the opposite. So we will go back to the initial value. There's nothing wrong with this. I don't think that it's going to cause any issues or any headaches down the line. However, you do have to be aware when doing this. If we make this game multiplayer, we will have to adjust it to be multiplayer safe. We can still use the add actor local offset, but we will have to keep track of the player so that we can notify. But now, if it's not greater than 0, it could be equal to 0, but remember we checked if value is equal to 0 here, not equal to 0. And since it's not equal to 0, we know that this else has to be less than 0. So if it's less than 0, we're tilting left or counterclockwise. We do exactly the same checks. This else is not required. You could do it all in one, but I wanted to show you with logs and with the negative actor local offset. So essentially we do, like I said, we do the exact same check. So we have the current tilt, make sure it is greater than the value that we want the minimum counterclockwise value to be, and that it is less than the value we want the maximum clockwise value to be. That way we're never going out of bounds of our tilting. Now, if you wanted to clean this up a bit, you could simply get rid of this. Okay, and now you can see what I've changed it to. I've essentially just made the if statement. I've taken out the if and else that determine if we're tilting right or left, and I've made it to where we still add the controller role input no matter what, as long as this if statement passes, but then we determine the offset to use based on the value. Because of this, I'm actually going to remove the log as well. But then let's go ahead and build this. So use whatever method you want. It's not really too much more efficient one way or another. This way is technically better, but it doesn't really matter. Make sure you compile once you get into Unreal. The other way for me was easier to understand, and I thought that it would be the same. But now you can see I can still tilt. That's a much simpler version of the function. Again, I think it's more complicated, but it's much simpler for the computer, and it looks a little bit neater. You don't have quite as much going on. So choose the method you want. Okay, now let's go into the else here, where we do else if the value is not equal to 0. So if the value is equal to 0, the character should be returning from their tilt. That's essentially what the logic we're going to do here. Let's go into it again. Has the character returned to normal stance from tilt? So now we're checking if the current tilt is not equal to 0. So this is not the same as the check above it. We were checking if the value is not equal to 0. The value is what the player is giving as an input. The value is essentially if they are pressing a button associated with this function, either num1 or num3. The current tilt is the actual role of the character. So if the value is equal to 0, then the character is not trying to tilt the character at all. Then we have to determine if the tilt is already at 0, so we don't accidentally over or under tilt them. We're just trying to get them back to 0. And then we go ahead and just do some checks here to make sure that we're within the proper balance again. So in this case, what we're doing is checking to determine if the current tilt is greater than or equal to 330. If it's greater than or equal to that, we know that we had previously been tilting left, and we are now returning to our default stance, our default untilted stance. However, we do have to make sure that we don't over tilt. You can't just say, oh, tilt. You know, that's not gonna, if we're trying to add control rotation back to the default value, we're gonna have to make sure that we are within the parameters that we want. Again, these are what can be variables, all these like floating numbers that are just out here. But I'm using them because of the degrees. This is 330 degrees. So remember that a circle is 360 degrees. We want to make sure that if the value of current tilt is greater than or equal to 330, we know that it is returning from tilt left back to normal stance, but we have to make sure it doesn't overshoot. So we have to check if the current tilt is less than or equal to 359. If it's less than or equal to 359, then we know we are safe to continue tilting in this direction because I'm only adding 1 as my controller roll input. Now you can change this value to be as much or as little as you'd like. If you made it 400, it'd be insanely fast. If you made it 0.1, it would be insanely slow. So feel free to change the values based on that. But understand here, you see how I'm adding controller roll input? If I wasn't using a value like 1 where it was so standard, right? It was so, okay, you'll never get a decimal if you're using 1 here. I would be able to overshoot. The important point here is that we're just not over tilting. So I have this as a check, and as the log says, the character is returning from tilting left. They were facing counterclockwise. We add the controller roll input. I use 1 as a default value, which does make sense because we're only using -1 and 1 in the function above. So you have the same rotation either way. You don't want to use value here though, because value right now is 0. So if you do that, you just won't tilt at all. And then I'm adding my actor local offset. I mean, in this case, I'm essentially adding it to where it's doing the same thing, but in the opposite direction. Remember when to tilt counterclockwise, we were using -2 for the local actor offset? Well, now we're tilting clockwise, so to return back to normal. So we want to add 2. These else's in here are just in case you don't want to have 1 as your value and you want to have some sort of decimal. You still need this check to make sure that you're not going to be above your max value. But this can go ahead and tilt the rest of the way for you. So say you landed at like 359.8. Well, you're going to have 0.2 that you have to roll backward to get to 0 on your pawn's rotation. However, we don't necessarily always know what that is. If you're using decimals, it could get tricky. It could depend on when the player releases the key and things like that. So just as an added safety check, I have this thing that has a log that says the character is ending tilt from counterclockwise. And essentially I take 360 and subtract current tilt and then apply that to the controller roll input. So again, if you're at 359.8, then this would come out to 0.2, and then we would add that roll input and you would be back at 0. We want to make sure we always go directly back at 0 because if we don't, it could look funny. It could have negative side effects for the player, and we don't want that. Now the rest of the logic is exactly the same as above, but for the other direction. Check and see if the current tilt is less than or equal to 30. Remember, 30 is our clockwise bound. We can't go farther than 30 degrees. So if it's less than that, we know we should still be returning from tilt, going counterclockwise to get back to 0. We do our check to make sure that we will be still above 0 by subtracting this next value. And I say the character is returning from tilting right, as we just mentioned. And then I go ahead and add controller roll input of -1, the opposite of this one above. And then the actor local offset is -2. Since to get to the 30 degrees and clockwise, we had to add +2. Now that we're going counterclockwise, we want to add -2. And then else, we make sure the character is ending tilt. Instead of doing 360, we actually do 0 minus because it'll get us a negative value. So that's important to note. I'm doing 0 minus the current tilt. Because imagine this. So imagine if current tilt, like say we had 0.2 in here. Again, let's do the same thing. So current tilt was 0.2. Well, we need a negative value to add to the controller roll input because we could do 360 minus this, but then it's going to do an entire circle and literally rotate the pawn to the opposite side. And technically it would work because it is going to do it all in one motion. But to avoid any headaches later on if you do any sort of blending or things like that, what you're going to want to do is just take 0 instead of 360 since they're the same and subtract. That way you can get the negative counterpart in degrees. So negative 0.2 degrees, and then we'll go ahead and add that to the controller roll input. And there you go. That's the entire function. This could also be simplified a little bit, just like I did to the function above. I'll leave that to you if you want. I'll keep all these logs in here so you can see it while I'm running the game. Make sure you build solution, go into Unreal once that succeeds and hit compile, and then you can play and you're good to go. If I walk over here and I show you my output log, you should now be able to see if I move this up a bit. So as I'm returning from tilt left, it says returning tilt left. Returning from tilt right is the same thing. Remember, since I'm using 1.0 and negative 1.0, it's never going to go into these else conditions for me here. The character is ending tilt. But if you don't like the speed that 1.0 gives and you have to change it to a decimal, this will still work. Just make sure that this if check allows you enough room to get back. And there you go, guys. So that's how we can tilt in our first-person shooter tutorial game. It'll actually work for any game where you have a pawn. You can control their rotation, and you can control the viewport with that. So, but in this case, we're doing it on the first-person project. So thank you guys so much for watching. In the next episode, I want to fix up where the weapons are going when we pick them up, and also clean up the way we actually spawn them. That way they don't have to be in the scene. We can just miraculously spawn them when we want to. And yeah. So thank you guys so much for watching. If you enjoyed and this helped you learn how to make your character tilt in your first-person game, please subscribe. It does more for me and the channel than anything else you can do, and I just really appreciate it. And I also wanted to give a huge shout out to my Patreon and YouTube membership supporters. Thank you guys so much for continuing to believe in me and support me throughout these different series that I'm making. I really appreciate it, and I'm very excited about what's to come. If you guys had any issues with this tutorial or any of the tutorials you've seen from me, feel free to join the Discord. I'll be happy to help you out with any issues that you had. Lastly, guys, if you want to come support us on Twitch, twitch.tv/Shawnthebro27, you can come check us out on Demon Souls or Little Hope from the Dark Pictures anthology. Demon Souls we have gotten surprisingly good at in the last episode. Complete change of skill level there. We were able to beat 7 bosses and only had 5 deaths throughout the entire 2-hour stream. So I am pretty darn impressed by that. Anyway, guys, thank you so much for watching. I'm Shawnthebro, and I'll see you in the next one. Goodbye, guys.